Hello, my name is Chris, and today I will be talking about a topic that most of my friends dislike when it comes to math, counting and probability. The problem I will be talking about is the final question of the 2022 AMC8. So if you took the exam, you should know what I am talking about. Let's go! A cricket randomly hops between 4 leaves, on each turn hopping to one of the other 3 leaves with equal probability. After 4 hops, what is the probability that the cricket has returned to the leaf where it started? This is obviously a problem related to probability, so let's talk about that first. A probability of an event is between 0 and 1, which means an impossible event's probability is 0 and a certain one's is 1. The formula, as shown here, is the desired outcome over the total number of outcomes. The hard part of probability is calculating these two parts. This is when we need to learn some counting techniques. First is the property of sum, also known as addition principle. It is basically the intuitive idea that if we have a set of ways to do one thing and another set of ways to do another, then there are A plus B ways to choose one. As shown below, we have 3 ways to go to another place by plane and 2 ways to go by bus. If we want to know how many choices we have to go, our answer is 3 plus 2 equals 5. Another property is the property of product, also known as multiplication principle. Like the addition principle, it is the idea that we have A ways to do one thing and B ways to do another, but this time there are A times B ways to do both. We'll take the previous example, but this time we will add a third place. We can go from the second place to the third place by train or car. We have 2 ways to go by train and 2 ways to go by car. Using the addition principle, we get that we have 2 plus 2 that equals 4 ways to go from the second place to the third place. But the problem is, how many choices do we have to go from the first place to the third place? So using the multiplication principle, we get that we have 4 times 5 equals 20 ways to go. Let's review with some examples. There are 4 types of books on Christie's bookshelf. 9 different novels, 5 different math books, 3 different English books, and 3 different science books. The first question is related to the addition principle. If Christie chooses one book from the bookshelf, how many choices does she have? Using the property of sum, we get that she has 9 plus 5 plus 3 plus 3 equals 20 choices. A little exercise here could be, what if she wanted 2 books instead of 1? We can use combination here, but that is not the main focus for now, so you can think about it later. The second question is related to the multiplication principle. If Christie chooses one book from each of the 4 types, how many choices does she have? Using the property of product, we can get that she has 9 times 5 times 3 choices, which is 405 choices in total. But what if, again, she wanted 2 or more books? I'll leave that question for you all to think about in your own time. Now, let's move back to the actual question and reflect on what we learned. The total number of outcomes is the total number of routes for the 4 jumps. The number of desired outcomes is the total number of routes for back to leave 1 after 4 jumps. Let's first try and find out the total number of routes by using the multiplication principle. In the first jump, the cricket has 3 leaves to jump onto. This is the same with the second, third, and fourth jump as shown. This means we have 3 times 3 times 3 times 3 routes, which is 81 in total. Obviously, the main focus of the problem is the number of desired outcomes. The easiest to understand but most complicated way is enumerating. This is one of the most basic things to learn in counting. Let's start. Let's begin with the first jump. First, we assume the cricket jumped to leave 2. First, the cricket could jump back to leave 1, to leave 2, then back to leave 1 again. Or, if I jump to leave 1, go to leave 3, and back to leave 1. Then jump from leave 2 to leave 1, leave 4, and leave 1 orderly. Then it might jump from leave 2 to leave 3, to leave 2, and to leave 1. Or maybe to leave 3, to leave 4, and then back to leave 1. Or maybe it will jump to leave 4, back to leave 2, and then right back to leave 1. Last, it might go to leave 4, to leave 3, and then back to leave 1. We will enumerate like this until we have no other ways. We got 7 ways if the first stop is leave 2. Then we assume the cricket jumped to leave 3 for the first jump and continue. We also got 7 ways. Similarly, we assume it jumped to leave 4 for the first jump and continue again. Last, we'll add all of these possibilities up to get 21 ways in total, which means the total number of routes for back to leave 1 after 4 jumps is 21. Wow! This is a long and boring way, however. You can use another tool, tree diagram, to facilitate the enumeration in a more organized and tidy way. Let's put this in the formula. We get 21 over 81, which can be simplified to 7 over 27. This means the answer is E. Still, however, could there be a better way? In fact, there is. Looking at this picture, does anything come to you? No? What this reminds of me is a ball passing game. Each leaf is a person and the cricket is the ball. At the very beginning, we will put 1 in the box as the person holding the ball. He or she can pass the ball to 3 other people if there are 4 people. However, they have no ball to receive from anyone else. This will result them to get a number 0 in the next row and the other people to get number 1. As we continue, we can see that similarly, the other 3 people can pass the ball to the first person, so the number we put for the first person is in the next row is 1 plus 1 plus 1 equals 3. For the other 3 people, they've only got 2 people to pass to them. The next number will be 1 plus 1 equals to 2. Next, the first person has 3 people to pass to them, but the other 3 people's numbers are 2, which means the first person's next number is 2 plus 2 plus 2 equals 6. Similarly, for the other 3 people, they have 3 people to pass to them, but their numbers are 3, 2, and 2, which means the next number is 3 plus 2 plus 2 equals 7. If we continue the process until the last step, we will get that the first person's final number is 21. This means the probability of the person getting the ball in the end is 21 over the sum of all the final numbers, which is 21 over 21 plus 20 plus 20 plus 20 equals 21 over 81, which is 7 over 27. We'll discover a pattern here. Every time a person gets another number, that number will be the sum of all the other previous ones. This is still the same chart but represented in a different way. The ball is the cricket, and each person is called a leaf. Since there are 4 leaves, there are 4 people, and since there are 4 jumps, there are 4 rounds. As we have calculated before, we get that the first leaf's final number is 21. A second method is categorizing the problem into 2 different scenarios, and then calculate with a multiplication principle. The 2 scenarios here are: first, if we don't jump back to leave 1 in the second jump, we will get that the first jump has 3 possibilities, the second one has 2, because we cannot choose leave 1, and the third one has 2 choices as well, because if we jump to leave 1 in the third jump, we wouldn't be able to jump to leave 1 in the fourth one. Using the multiplication property, we have 3 times 2 times 2 choices equals 12 choices. The second scenario is if we do jump to leave 1 in the second jump. This means we have 3 choices in the first jump, 1 in the second jump, because we need to jump to leave 1, and 3 in the third jump. We'll jump back to leave 1 in the fourth jump. Using the multiplication principle, we have 3 times 1 times 3 choices, which is 9. Last, we will use the addition principle to get that 9 plus 12 equals 21 choices. We get the same answer, 21 over 81, which is 7 over 27. Hooray! Counting and probability is a hard topic, but if we study hard, it'll become easier. Think hard, think smart. We love math.